Let us look at the conformation of cyclopropane. As we mentioned, the cyclopropane has a high bond angle and torsional strain. So, if you look at the molecule is basically planar. This is what we have seen earlier. So, the C3 molecule is basically planar, and if you look at the geometry, this is basically a triangle. Equilateral triangle is the one which we have actually shown here. So, the bond distances between carbon is 1.510 angstrom, and in the other case carbon hydrogen bond distance is 1.089 angstrom, and the hydrogen carbon bond angle is around 115 degree. This is the external one, and if you look at the internal carbon bond angle, it is close to 60 degree. So, that is where we call this as a equilateral triangle. And here we can actually see the eclipsing of hydrogen atoms. If you look at the front and the back hydrogen atoms, they are actually in the eclipsed conformation. So, as we know, when there is an eclipsed conformation, what actually happens is there is a lot of torsional strain. So, in the cyclopropane, we have both the high angle strain as well as torsional strain. So, this is one of the reasons the molecule is highly unstable. And let us move on to the cyclobutane molecule. So, cyclobutane has a considerable angle strain, but not like a cyclopropane molecule. Here the bond angle is 88 degree given, it is roughly 90 degree, close to 90 degree. So, this compound, the cyclobutane, exists in a twisted form because this twisting actually releases some of the torsional strain. So, that is the reason the molecule actually has a little bit twisted from the planar form. So, this is having a little bit, if you look at the structure, this is not a completely planar molecule. The molecule is actually close to the planar molecule, but this is little bit twisted to relieve the torsional strain, because the eclipsing hydrogen atoms will have the torsional strain. So, to avoid that, the molecule twists a little bit, and this also leads to little bit distortion from the tetrahedral angle and also from the square angle. Here the substituents are basically in the eclipsed orientation. If you look at the planar and the puckered arrangement for the cyclobutane, because these are the two different arrangements that are possible. So, we have seen that one type of arrangement is a planar arrangement because this is a cyclobutane. So, it is like a square. So, this is a square planar arrangement. That is why this molecule exists in the planar conformation. Of course, the molecule also exists as a twisted thing, like a little bit of deviation from the plane. If you look at this carbon, and these three carbons are in the same plane. The fourth carbon is little bit above the plane. So, there is a small amount of twist present just to relieve some of the torsional strain in this particular molecule. So, this arrangement is called as a puckered arrangement, and in fact, if you look at the energy difference between these two conformations are very low, approximately close to 1 kilocalories per mole. So, that is the reason the molecule can move from planar conformation to puckered conformation very effectively. And in fact, the compound, the dicarboxylic acid in the solution form is shown to exist in the planar form. And when we talk about the dibromo derivatives, because of the bigger size of bromine atom, they are actually present in the puckered arrangement. So, this way we can actually isolate the individual compounds and characterize which type of conformation is present in these kind of molecules. So, in other words, cyclobutane exists as both planar and the puckered arrangement because the energy difference between these two conformations are very less. So, they interchange between these two conformations. The next one is the cyclopentane conformation. So, here cyclopentane has considerable torsional strain, and to relieve that considerable torsional strain, what it does is it actually bends a little bit more. So, in this particular molecule, if you look at there are 5 carbon atoms. So, let us number that as 1, 2, 3, 4 and 5 carbon atoms are there. Out of the 5 carbon atoms, 1, 2, 3 and 5 are in one plane, and the fourth carbon is little bit above the plane. So this is like a envelope arrangement, or very similar to an envelope like thing we generally call. So one of the carbon is little bit above the plane of the rest of the 4 carbon atoms. So in other words, what we can say is 4 atoms are in one plane, and the fifth one is not in the plane, it is either above the plane or below the plane. So here again there is a slightly distorted bond angle from the tetrahedral arrangements, and substituents will have eclipsed strain. So to relieve that, this kind of little bit of bent or the puckered arrangement is present in cyclopentane. So here is another conformation which you can see actually. So carbon atom 1, 2, 3 and 4 carbon atoms are in the same plane, and the fifth one is actually pointing downward. So in other words, if you look at the carbon atoms, so 1, 2, 3 and 4 carbon atoms are in the same plane, and the fifth one is actually little bit down. So that is how we can actually look at the cyclohexane conformation, cyclopentane conformation.